Okay, we're going to get started. We still may have some people joining us. And for some of you are here because you're in the class, and you know if you weren't here tonight, you'd flunk the course. But others are from the general public, and remember, this is the fourth of our 4 class sessions, and because some of the funding came from the Water Replenishment District, what we said was that the first and the final lecture would be open to the public. This has been a very interesting course on California's water, past, present, and future. Jeanine Jones, who I will introduce in just a minute, really has been the architect of this course. And if you haven't looked at the new exhibit that Jeanine and her colleagues created for us, it's up on the 2nd floor, it really is worth taking a look at. And she'll give you an overview, but let me just say a few things about it. The idea was to bring experts in to talk about California's water, past, present, and future. We started with the big picture, and we talked about droughts in the 2nd class, and then floods, and then tonight we're going to look at the effects of climate change and what it may mean to California and all of our water issues. And so there will be time at the end for some discussion, and we hope that all of you will ask some good questions. And we appreciate those of you who are not taking the course being here tonight. Jeanine Jones is the California Department of Water Resources Interstate Resources Manager. She was previously the Drought Preparedness Manager. She's been with the Department of Water Resources for more than 30 years. And she has done everything from directing statewide planning, participating in interstate water negotiations, working on climate change adaptation. She's published numerous technical reports on water. She's taught courses at UC Berkeley through Extension. She serves on the Western States Water Council, the Colorado River Board of California, the U.S.-Mexico Border Governor's Water Work Table. She's a registered engineer in California and in Nevada, and has a bachelor's and a master's degree in civil engineering, and is a member of the American Society of Civil Engineers and the American Water Works Association. And I'm going to introduce Kevin now. Kevin will talk after Jeanine, and depending upon what the time is, I may make some comments at the end. Kevin Wattier is the manager of the Long Beach Water Department. And I think among all the water departments in this state, it is one of, if not the best managed and led. It certainly is in the very top. It really is quite an innovative department, and the things that have been done to provide resiliency in the face of climate change or in reduced supplies and so on. Kevin has 230 professionals who works for him in Long Beach, the 5th largest city in our state, and it operates one of the largest groundwater treatment facilities in the United States. He worked for 13 years with the Metropolitan Water District, and then before coming here, he was with a consulting firm for 2. He's a professional engineer, registered in the state of California, and he is a certified water treatment operator. He has a bachelor's degree in civil engineering from South Dakota State University and a master's degree in environmental engineering from Clarkson University. And when he moved to California from South Dakota with his family, the population of the state went down by 40%. It's good to have both of them here. So Jeanine, you come up and give some comments and give your talk, please, and then we'll have Kevin.
Okay, well, thank you, Jerry. And just as a little recap of what we've talked about in some of the previous lectures, we started out with the California Water 101, and in that we talked about a few points, including the fact that what happened in the gold rush era actually defined a lot of our current water infrastructure, surprisingly enough. And we owe a lot of the way that our water system has developed to things that started happening in the gold rush. We also heard a lot from Kelly Redmond about the variability of California's water and climate. And if you remember, for those of you here for the first lecture, we talked about how California experienced a tremendous flood in 1862, that was a really big deal at the time, followed immediately by 2 consecutive years of drought that pretty much was, between the floods and the droughts, the death knell of the cattle rancho era in California, and a transition to a different type of agriculture, really illustrating the variability of just the natural variability of our climate and our water system. Then in the second lecture, we talked about drought, and we again talked about some of the variability that has been experienced over times longer than our short period of historical record, which is only about 100 years, more or less. And Connie Woodhouse from the University of Arizona showed us some examples from tree ring chronologies. The Colorado River, for example, the multi-decadal drought that occurred in what some people call the medieval climate anomaly, that would be the scientific terminology, or what others more colloquially call the medieval megadrought, a time when conditions were much, much drier than they are now. And if you look at our exhibit upstairs, you'll see a photo of the National Geographic submersible looking at the trees that were growing in what is now the underwater in Lake Tahoe, but at the time it was very much drier than it is now, allowing these trees to take root and grow. So we know that we've experienced droughts in the not too distant past, much more severe than our short period of historical record. And in last week's lecture, we talked about floods and talked about the fact that we've also experienced some really big floods, and something that particularly intrigues us in Northern California is that in the first half of the last century, we had a fairly not too exciting time as far as floods go, and that's good. We don't like excitement. But then in the second half of the last century, we saw a major increase in big floods on the major rivers in Northern California. We don't know why. We'd love to know why. Was it natural variability? Was it an early impacts of climate change? But again, highlighting the variability of our climate. And in fact, we also mentioned at the last session that within just the space of a few years, California, in terms of statewide runoff, experienced both its driest ever statewide runoff in 1977, and then in 1983, shortly thereafter, its wettest ever year in the record. And we also talked about local flooding, as for example here in Long Beach in 2010, when there were 2 storms, one in January of 2010, the other in December, in which daily precipitation records were broken for Long Beach, and both of which caused some stormwater flooding, which is a kind of event that we would expect to see more of as an impact of climate change. So tonight we'll be talking more about the climate change side, and this is what I'll be covering, starting out with where we've been. One of the interesting things about climate change is that this is a really pretty new topic in the world of water, and it's amazing how quickly, relatively speaking, that this has gone through a period of scientific development and is now leading to policy decision making. The first assessment report by the Intergovernmental Panel on Climate Change, or IPCC, was published in 1990, which, is pretty darn recent, relatively speaking. And then a series of reports at periodic intervals after that. The last one was published in 2007, and work on the 5th one is now underway. But a big difference in the consensus and understanding in the science world about what climate change might mean. Here are a couple of the major conclusions from the 1990 first assessment report. Well, the first one is awfully basic. Greenhouse effect exists. Pretty hard to argue with that. That's sort of a basic kind of science fact. That wasn't too earth-shaking. And maybe human emissions have something to do with that, with warming. That's not a very strong statement. But if we skip forward now to the most recently published assessment report, they have a lot more conclusions, and the language has gotten a lot stronger. And in the IPCC process, they actually have a system that they use for characterizing how certain they are of things. So, for example, when they say very likely, that means a specific level of confidence that they have in that statement. So they basically say that, hey, it's been warming for a long time, since the Industrial Revolution. Warming of the climate system is unequivocal. That's a very strong statement in terms of IPCC. Most of the observed increase is very likely. due to activities of people, and particularly important for those of us who work in natural resources areas. Anthropogenic warming and its concurrent effects will be continuing for a long time, basically due to the inertia in the climate system. So even if we stopped doing everything now associated with excess emissions, we would still see these effects persisting for centuries. And that's a really important thing to think about if you're thinking about climate adaptation. So this is what the world of science has been saying. And at least in California, which has been a leader in this whole area of climate change, this has been adopted very, very rapidly into policy. So think about the first very lukewarm report that the IPCC put out in 1990, and then, maybe about 15 years later, you start seeing significant policy actions happening. This is really an amazingly fast transition for something that is as both complex and, frankly, controversial to some people. And see, California has been doing a lot of things in climate change. And since Jerry made the comment about South Dakota, I do have to point out that something we talked about in the earlier classes was that really when you look at the effects of extremes, droughts and floods, it really boils down to local impacts in either case. Just like the saying that all politics are local. Well, how do you define a drought? Well, it's when your own water supply is affected, a very locally perceived impact. Same way with floods. Well, your views on climate change are also affected by where you are. Or as the former governor of Arizona and former Secretary of the Interior, Bruce Babbitt, once famously said when he was asked why he had changed a position that he had held when he was the governor of Arizona, when he became the Secretary of the Interior, where I stand depends on where I sit. California has, perhaps a lot to lose, so to speak, with climate change. And when we talk about climate change in California, we often speak of it in a negative way, more commonly than not. However, when you try to work with other states and form coalitions on climate change, if you talk to North Dakota, they don't see a problem here. I mean, if you're North Dakota, warming, a little more water supply, this is a good thing. So it is a question of, again, what are your local impacts, because that is going to drive how you think about it and how you act on it. But California, knowing that we have vulnerabilities because we have such a very large population, huge economy, we have a climate that is highly variable naturally anyway, regardless of human interference, so this is going to be a big deal for us. And in fact, the governor's office announced last week that the governor will be convening a policy conference next month on climate change and extreme events. And we expect some of the earliest, shall we say, troublesome impacts of climate change to people in California probably will be coming from these extreme events, and that's something I'll talk about a little bit more later on. So, what's the bad news here for California? Well, essentially summarized on this slide, as greenhouse gases increase in the atmosphere, we start to see implications of those with respect to warming. Reduced snowpack, which we talked about at a little bit in the first session, which is very important not only from water supply and hydropower, but also from the flood control side, because our whole system of water infrastructure wasn't designed to deal with this. Sea level rise, which is an issue for everyone living in low-lying areas along the coast, and also very important for the Bay Delta, which is hugely important for California's water supply and for the water supplies that are imported here to Southern California. If it gets warmer, water demands increase, whether it's urban water demands or agricultural water demands, because plants need more water. And as we talked about in the drought session, when things get drier, water demand actually increases, because if it's not raining, you have to water your lawn more, you have to irrigate your crops more. And then one of the catchphrases out of the last IPCC report in 2007 was sort of the soundbite or the bullet that extremes become more extreme. So in other words, droughts become more severe or maybe occur more often, flooding maybe occurs more often, or you get a few really big events that you hadn't seen before. So they say two things about it, actually. Extremes become more extreme, and wet gets wetter, dry gets drier, are sort of catchphrases to characterize it. So one of the things that people comment about when they talk about climate change is, well, yes, but there's a lot of uncertainties out there. And there certainly are uncertainties associated with things like the global climate models, or GCMs, that the academic community runs to analyze the impacts of climate change. One of the things that actually has improved greatly over the course of the IPCC assessment reports is the capabilities of the models to look at things on a finer and finer scale. The earliest versions of the models looked only at the atmosphere. They didn't include the ocean. Well, guess what? If you look at a globe of the Earth, which do we have more of, ocean or land? Okay, so and the ocean is a huge heat sink, so that was very important. But also, as they got better and better at this, they were able to improve the scale of the model. So instead of looking at modeling grids that were very large, they're able to look at modeling grids that are much smaller. And one of the things that's very important throughout the western U.S. is mountain ranges. Because basically, mountain ranges define much of our precipitation patterns. You know, clouds come in from the ocean, they hit a mountain range, rains a lot on the seaward side of the mountain range, go over on the other side, it's dry. Think of the Sierras, for example. So the ability to do what's called regional climate models is greatly improving that aspect of uncertainty. Models are increasingly agreeing in temperature relatively well. Precipitation is harder for them to do. And some of the things that we're most interested in terms of near-term impacts, severe weather and sea level rise, are sort of the ongoing focus of major research. Some of you have probably seen the popular press articles about the loss of the seasonal Arctic ice cover, or the loss of mass from the land-based ice sheets, which is what contributes to sea level rise. Difficult to measure and model, but the science world is realizing that this is very important to being able to predict future sea level rise, so it's an area of increasing research attention at this point. So, but one of the biggest issues in looking at impacts of climate change is predicting what people are going to do. It's actually much easier to predict the behavior of a physical system than it is to predict what people are going to do. And by that we mean, what's the emissions path? Well, for those of you who've been watching the news on this subject, this may not be as much of an issue as was originally thought, in part because the emissions keep going up. So it's really not a, well, are we going to be at the low emissions level or the medium emissions level or the high emissions level in the future? It's certainly looking like we're going for the higher emissions trend at this point. And this is just a graph that illustrates the sensitivity of looking at different emissions scenarios in terms of the farther out you go in the future, the more difference it makes. And in fact, up to around the middle of this century, most of the climate models are, fairly close and then start diverging considerably. But as I said, if the emissions trends continues as with what we're seeing now, this may not be such a difficult projection to make, because we know we're going to be on one of the higher lines. So what does it mean for California? So this is looking at temperature. And this is what I meant by saying, the extremes get more extreme. So the heat, let's see. Oh, there we go. Oops. Well, forget the laser. We'll give up on that. But anyways, if you look at places like the Central Valley or the desert areas in the southeastern part of California, you can see a distinct trend in warming. And you also see that in places like the Sierra Nevada and the Cascade Mountains, which are very important to us from Snowpack, that area is starting to get a little more colorful as well, which is not good news for the Snowpack. And so this is looking at, the last one is looking at end of century. If this is California, think about some other areas in the U.S. Southwest. Phoenix, for example, in 2007, set a record for number of consecutive days over 100 degrees. They had over 100 days. So think about Phoenix, let's say, in 2090 or 2100. you know, you probably wouldn't find that too appealing to live in. And one of the things that, when I said predicting the behavior of people is difficult, one of the things that's difficult in these kinds of scenarios is to predict at what point a change in climate may change demographics, change where people choose to move to or to live, which in turn affects water demand. And this is something that we've simply, you know, do not have the ability to model, because demographers are not at the point where they know how to incorporate climate, for example, in demographic forecasts. And here's our loss of snowpack graph. And this is hugely important to us because the snowpack in the Sierra Nevada and the Cascades is roughly equivalent to about a third or so of the state's developed water storage capacity. And this is showing the loss in April 1 snowpack, which is traditionally taken as a time of maximum snowpack accumulation in the mountains. Well, we operate the reservoirs in the Sierra Nevada and Cascade system very carefully to balance between flood control and water supply. And our whole system of water infrastructure is really hugely dependent on runoff from these mountain sources. We talked about in the class before this one that Southern California has historically gotten about 60% of its water from imported sources. Half of that from the Colorado, the remainder from the State Water Project and the Los Angeles Aqueduct, both of which are draining the Sierra Nevada. So as those resources are subject to more pressure from climate change, it becomes problematical for areas like this that are relying on a lot of that for their imported water supplies. And you know, we do have relatively aging water infrastructure at this point, and it would not be easy or cheap to do a lot of work to rearrange things, so to speak, to reflect expected changes in hydrology. So the major challenge for the Sierra Nevada is this balancing between water supply and flood control. We mentioned in one of the earlier classes about the Colorado River system, which gets about 85% of its runoff from about the upper 15% of the watershed in the upper basin, very high elevation mountains. So the good news is that the impacts of climate change will be slower to manifest themselves, and in the Colorado River system you have a huge amount of storage. The storage capacity on the river system is about 4 times the average annual flow volume of the Colorado River. If you come to California and look at the Sierra Nevada and the Cascade systems, it's really more like the reverse. Most of the river systems, the ratio of storage capacity to average annual flow it's not 4 to 1, it's more like the other way around, or 1/4 to 1, something like that, 1/2 to 1. And that gives us very little margin of error when we're trying to balance the need to try to hold carryover storage for water supply, but at the same time deal with flood control needs, especially in the San Joaquin Valley. There are some potential things that we can do in the next few decades that will buy us some time before we have to perhaps look at major revamping of the infrastructure. Reservoir reoperation using forecast-based operations. And that was talked a little bit about in last week's class when we were talking about atmospheric rivers and the idea of an atmospheric river observatory system, a system of very advanced weather monitoring instrumentation that's being installed in California now that will help us get a little better lead times on forecasted storms coming to California, especially the big ones that have the major flood control potential. But that really is an interim activity in the next couple of decades, but something that we will have to continue to work on as we think about how to deal with this challenge, which from the statewide perspective is probably one of the biggest ones. And just a reminder that much of your water here has historically come from someplace else. And one of the things that you see in Southern California is that you don't have a whole lot of storage capacity within Southern California. You've essentially been relying on what in other places would be called a run-of-the-river sort of system. In this case, the rivers happen to be made out of concrete, and they deliver the water down here. But the largest surface water reservoir in Southern California is MWD's Diamond Valley Reservoir out in the desert area near Hemet. And then pretty much everything else is groundwater storage facilities. And that makes the flood control aspect a little bit challenging. Some of you know, I'm sure, that Los Angeles County Department of Public Works operates small debris basins up in the San Gabriels, for example, where they try and catch some of the flood waters, knock the peak off, and then slowly flow them down the channel and allow them to recharge groundwater basins. This is something we're going to be needing to do more of, developing more groundwater storage to compensate for some of the losses we expect to see in the future, but also we need to think about improving the flood control system. Now, in terms of knowing that your imported water sources are going to increasingly probably become less reliable over time with climate change, and also we certainly have the questions about the Bay Delta that remain to be fixed. The thought is that Southern California in particular needs to improve its development of local resources, and this is just a laundry list of sort of the usual suspects. There's really nothing magical about adaptation to climate change. It really just is another stressor on our water infrastructure system, the same way that population increases or new environmental requirements can be stressors on an existing system. So we know there are measures that we can take to deal with it, but it requires the political will and the funding to put those in place. And not to forget the flooding aspects. As we talked last week, although Northern California is, of course, the much wetter half of the state and one where the major threat from flooding is much larger simply because we have way more water to work with, and we have these old levees that date back to the gold rush times that are not in very good shape. Here in Southern California, you do have the potential for some very high intensity, short duration flood events, in other words, flash flooding type systems. And we mentioned that the record for single day maximum precipitation in California is actually in Southern California at Hoji's Camp in the San Gabriel Mountains, 26 inches in 24 hours, which is a pretty scary number. And again, that's just because of the relative location of that mountain range close to the ocean and in a good position to intercept some storms that are coming in with a very wet storm track. There are things we can do to deal with this. A lot of potential more in the Inland Empire area where there's still a lot of new development going on for floodplain management, using zoning and building codes to try and prevent some of these flood problems before they happen, rather than in areas which have already been built out, whether it's the Los Angeles River Basin or Sacramento Valley, where we're faced with protecting existing infrastructure, because as we said last week, when people first moved into California, they did what everyone did in those days, which was to settle right in the river basin, right in the river valleys as close to the river as possible, because that was where you wanted to be. The water supply was there, you used the rivers for transportation, all those things. We now know from a flood control standpoint it would be much more desirable not to live quite so close to those rivers. So certainly there are things we can do in this area, and we do have a National Research Council study underway now on sea level rise on the West Coast, and associated with that, we, the Department of Water Resources, are taking a look at the idea, or taking a look at the scope of coastal inundation and flooding associated with what we expect to be the nearest term effects of climate change, which would be things, the increased storminess, the storm surge events, El Nino years when you already have high sea levels, get a big storm in on top of that, higher potential for local flooding. And frankly, to us, it looks like one of the early problems is going to be many of the local stormwater systems in low-lying areas. So in this part of the world, that could be parts of Los Angeles and Orange counties, for example. And in Northern California, around the shoreline of San Francisco Bay, which is very topographically flat. So what are the kind of time frames when we think about how we adapt to climate change? Some of course, climate change, kind of like drought, it is a phenomenon that is gradual and gets worse over time. And if we're talking sea level rise, for example, we're talking maybe 55 inches as the high range number at the present at the end of the century. But by 2050, we're only talking about maybe a foot or so. So those are numbers that you think about when you think in terms of your planning horizon for infrastructure, for building projects, for land use planning activities. And certainly it's desirable now in terms of the decision-making time frame to say what impacts can we avert at this time through basically institutional controls, land use planning, zoning, building permits, those kinds of things, so you don't build something that you know that by mid-century may be in harm's way, or mid-century or later. If you have existing infrastructure that you have to protect and think about, most public agencies use a time horizon for capital outlay planning, something in the 30-year kind of framework. So when agencies are thinking about water supply planning, what they're going to build in the next couple of decades, they have some lead time to think about, well, gee, if I need to improve my stormwater system, and many areas in the state now have stormwater systems that are rapidly approaching the 100th year. They're approaching their 100th birthday, I suppose you could say. We know we have a lot of aging infrastructure in the state that needs to be upgraded and improved. This is an ideal time to start thinking about incorporating what you're going to do to respond to perhaps more severe flood events, things like that, more severe extremes into your planning. And at the operational budget level, which is sort of your annual or biennial budget cycle, there you really are thinking about the response to extreme events, the need to perhaps position some resources differently in terms of emergency preparedness activities. Actually, both Kelly Redmond and in last week's session on flood control, there was mention of the ARC storm event, which local agencies and California Emergency Management Agency and USGS were using as what would happen if a really big major flood event hit California. That gives you some guidelines as to things you might want to fix within the next few years, so sort of an operational level of budget planning. Just as on the drought side, one of the operational or near-term lessons that we've learned from past droughts is that it is very beneficial for the larger water systems to make sure that they have all of their interconnections with other systems in place to allow for emergency transfers of supply or emergency connections. If you looked at the history of drought in California and went back to 1977, which was our single driest year of the record, you would see that one of the problems that many systems experienced at that time was because there was very little interconnectivity, few emergency connections, little ability to make things work for an emergency water transfer, and California has really come a long way in that regard. So this is one place where we're well ahead of the curve. And if you look at states like Texas, for example, which is one I always like to poke fun of when we're talking about drought, Texas, pretty dry state in much of the state, but they have really not much in the way of major water infrastructure like we have in California, and they have no ability really whatsoever to respond for drought other than to pray for a hurricane. Well, sometimes that works, sometimes it doesn't. But the fact that we do have this very intensively developed system of water infrastructure in California does give us a big head start on being able to respond to some of the challenges that we think that climate change will bring. And the real challenge at this point is to develop the political will and support to move forward, update some of our aging infrastructure, encourage people to think more about water conservation, water reuse, and focus on things like stormwater, which we've historically dealt with by trying to get it out of the way as quickly as possible without maximizing full use of that resource for water supply purposes. So I think this is where I will wrap up here. And this is from the wetter Northern California perspective here.
So before Kevin starts, we have time for maybe a couple of questions or comments.
Well, so I think what's interesting is to look at the 2050 and then the 2100 projection being a foot and then 55 inches. And although we'll never see it, I mean, you look at 2200, you're looking at some drought, because it's obvious it's going up like this, the sea level rise. So has anybody, what? Yeah, it's going exponential. Has anybody looked at 2200? I have never seen any actually projections that far out.
I've seen some stuff in IPCC reports talking about global sea level and alluding to the fact that if you go out several centuries, well, you know, we won't miss Florida that much. Which has historically had a long geologic history of being underwater, above water, underwater, above water. But most folks outside the climate modeling community don't pay a lot of attention to those longer term simulations because they recognize the, you know, the difficulties associated with the modeling at this point.
But I mean, 10 meters, you wipe out quite a bit of San Francisco Bay Area.
Yep.
You don't even have to get that far. So California, we've been a leader in terms, at least of policy. We've said, but policies are pronouncements of good intentions. And when you look at California, most of our pronouncements have been on mitigation to reduce the emissions of greenhouse gases. We did California Adaptation Strategy 2009, but when you look at mitigation, we should do that. We should do it because it's the right thing to do. But what California does is going to have very little effect on the global emissions of greenhouse gas emissions. That will be dominated largely by what China and India do. And given that we've got a population now of 37 million, a water system that's extremely vulnerable, we should be putting the center of gravity on adaptation. I don't think we are. Now, you're with the state, nobody's listening. Well, you can tell us the truth, Jeanine. Are we putting enough emphasis on adaptation other than this making a statement?
It's hard to get the attention for adaptation as compared to mitigation, and the support that the state would be putting in that direction is really through the bond monies that are going into various, you know, financial assistance programs for local agencies largely, which in the long run, if they help floods or help droughts, are a means of adaptation.
And we talk about the uncertainty in climate change, and there's a lot of uncertainty, but the direction is very clear. How it will play out at local and regional levels is unclear. How much greenhouse gases will go up, there's uncertainty. But we know that it's going to be a warmer Earth with a higher standard sea level. You can go right down the list. I was at a policy seminar at the RAND Corporation a few weeks ago, and the speaker, who's a very smart guy, he said there's so much uncertainty in climate change, it would not be prudent for the state to make a big investment now until the uncertainty is reduced. And in the comments, I said I thought it was a very irresponsible comment to make. Do you think we should be holding off?
You know, even if we were not worried about climate change, we have plenty of other stressors to worry about, like population and et cetera, and we should be getting ahead of the curve rather than behind it. We've essentially been living off of a lot of infrastructure for which the investments were made in the 1950s and 1960s, and that infrastructure is aging. We've got a lot more people. It's getting to the point where we need to step up to the plate and do something about it.
That's right. Now, we're going to hear.
But I wanted to comment on Janine's last slide before I got onto my speech. I'm originally from South Dakota, as Jerry said, but you know, one of the places, you know, there's a few places in the country that don't drain, and one of the places in the country that doesn't drain naturally is Devil's Lake, North Dakota, and I have a good friend who works in transportation in that part of the world, and he sent me a slide presentation a couple weeks ago from Devil's Lake, and I wish I'd have thought to bring some of those slides. You would have just been absolutely amazed. They don't want any more rain in southeastern North Dakota. Devil's Lake in the last 20 years has grown 7 times in size, from about 120 square miles to about 800 square miles, and it's continuing to rise, and they're having to make really difficult decisions about who gets flooded out next. Farmers or the cities, or they spent hundreds of millions of dollars raising roads and levees and things. So that's just a sideline. But I wish I brought some pictures. There's some really poignant pictures I have of, you know, a little country church that's on an island that there's no way to get to it. You know, I mean, think about that. I don't want to get emotional, but think about that. That's your family church where you grew up. You can't get to it. It's, I mean, let's say a helicopter, you can't get to it. It's on an island completely surrounded by water. Anyway, that's a sideline. I've given various versions of this presentation, and I seriously, I don't think anybody could disagree that one of the adaptations to climate change that we should all be making in California is conservation. Serious conservation. No matter whether it's 1 foot or 5 feet or 10 feet. I remember, as Jeanine said, this is a fairly new topic, or it's moved pretty quickly. I remember in 1987 when I was at MWD, and I was actually the liaison with DWR, who Jeanine has worked for many years. I was given the assignment to go up, get this young professor from UC Berkeley, who Jerry and I know, and bring him down to have us tell us, what's this climate change thing you're working on? And that was Peter Glick, who I'm sure we've all heard of Peter, and he was doing his original climate change work at Berkeley back in the late 80s, and what he said, I think, has turned out to be true, is, in California, what's clear with climate change is it may be wetter, it may be drier, but clearly we're going to have more rain, less snow. Reservoir operations, as Jeanine said, become more and more difficult between operating reservoirs to provide water supply versus flood protection. That's what we're seeing. I mean, we're actually seeing, I watched this very carefully over the last few years. You're seeing earlier snow melt, less rain, or more rain, less snow. And as Jeanine said, the Snowpack is our biggest reservoir in California, and it's going away. So it's moved pretty quickly. That's 24 years ago, and here we are. So anyway, the thesis of my presentation is conservation. It's all good, and of course, I'll explain to you how we make sure that happens. This is an interesting slide. It's from the U.S. Bureau of Reclamation. I'm going to talk about, as Jeanine said, about half of our water here in Southern California is local, and about half is imported, and the two main imported supplies are the Colorado River and the State Water Project, which DWR operates. This is kind of the supply and demand of the Colorado River, going back to the 1920s here on the left, and it goes out to about 2004. We here in Southern California, the way the Colorado River allocation works, we were the beneficiaries of this gap. The way it works, MWD, which provides us imported water supply, they're the kind of the last one on the totem pole in terms of the Colorado River. But because we've had, until recent years, we've had these huge surpluses of Colorado River water. The demand, the supply is this purple line up here, and the demand on the river is this blue line. MWD for many decades benefited from that huge surplus. Well, that's all gone now. The demand and the supply in the Colorado River are about the same. Arizona and Nevada and those other states are pretty much using their full allocations, and so the days of surplus water on the Colorado River, on average, are gone. That's today. That's not climate change, or that's not forecast. That's what's actually happened. So let's talk about forecast. Again, this is a graph that I've seen in a couple presentations. This is a very interesting graph. If you want to move to North Dakota, it'll get wetter. If you want to move to Alaska, it's going to get wetter. What this graph's showing is they looked at 25 different climate change models, and how do they agree? And these are based on major river basins throughout the country. And so for example, 100%, as the Alaska number shows, means that there's 100% agreement that all 25 models agree it's going to get wetter in Alaska. Well, if you look at the Colorado River watershed, that's this red one right here. 24 out of 25 of the climate change models agree it's going to get drier. And they say it's going to get drier somewhere between 10% and 25%. Now that's that's an additive to the previous slide. So the Colorado River is getting drier, and that's one of our major imported supplies. But now let's look at the yield of what's called the Table A allocation of the State Water Project. This is again something that DWR operates, and every few years they're required to update their what they call their State Water Project reliability estimates. And this is what's happened to the average annual basically water supply in terms of the contracts that MWD and others have on the State Water Project. In just 10 years, or really just 8 years, it went from 72% to 60%. That's mainly, Jeanine would know this more than I, it's probably more due to environmental regulation than it is climate change. But there's been a lot of environmental regulation that's restricted the ability of the State Water Project to provide water to its contractors, including us here in Southern California. So that's obviously a trend line that's a little bit disconcerting if you're relying on the state water project. So that's just to give you a little background on what's happening with our imported supplies. And of course, again, my thesis here is conservation. It's all good. We should all be doing it. We should all be very serious about it. And we're very proud of what we've been able to accomplish in Long Beach. This is our month-by-month water conservation in Long Beach for the last fiscal year that just ended for us in September. We're very proud of our performance here. We're down about 16.5% compared to our historical average. And some of the statistics on the bottom here is our potable water consumption. And this is not just because of conservation; it's because of recycling also. But our potable water consumption in Long Beach is the lowest it's been since 1966. And our per capita potable water consumption is the same as it was at the end of World War II. So those are just some statistics. And the point I'm making is this is not a big deal. This is very doable, very achievable. We should all be doing it, and we're glad to be helping lead this effort. Because we're not alone. These are various numbers that if you read the papers over the last few years, you'll see that everybody in Southern California is doing about the same thing. 15 to 20% conservation throughout all of Southern California been achieved. I remember sitting in meetings a few years ago when people said stuff like, we're so drought hardened we couldn't possibly conserve more than a couple percent more. We've done everything. We've changed out every toilet. We've done everything. There's nothing left. Well, that's all BS, and that's really what I'm here to talk about. We've done 17%. Long Beach is still here. I haven't heard of a single person or a single business that's made a business decision to live here or not live here or move here or not move here because we're using 17% less water, and the same is true in Los Angeles and San Diego and everywhere else. Yeah?
Just curious, where did they lump Orange County into? LA, San Diego?
Well, these are actual cities. Those are cities. Those are the cities of Long Beach, Los Angeles, and city of San Diego.
Percentages relative to
Relative to, well, the way everybody does it a little different. But the way we do ours is compared to the 10-year period of 1998 through 2007. That's what we consider to be our baseline. It's kind of the same basis upon which the 20 by 20 regulation is based. That's kind of your baseline, is that general 5 to 10 year baseline before 2007. So they're all on a similar baseline of about that time period. Everybody does their numbers a little different, but they're all similar. Again, the point is, everybody's doing this. It's been achieved, and clearly we've accomplished things that I think a lot of people didn't think could be done. But we're nowhere close to where we can be. That's the point of my thesis. Here's just a couple things that we're working on, and I think are very, very exciting things that will allow us and allow other water utilities to keep pushing conservation. Automated meter reading. This is a technology, I don't have any graphics on it, this is a technology that we've been talking about for 10, 15, 20 years. We've all been sort of hoping that someday this would get here. It's a technology that now has become mature. Basically what it is water utilities aren't the only ones doing this. Electric utilities are going to automated meter reading. SoCal Gas is converting their whole system right now in Southern California to automated meter reading. What it is using radio technology to read the meter. The reason this is important from a water conservation perspective is most utilities right now only read the meter once a month. Some only read it once every 2 months. Well, if you have a leaky toilet at your house and we only come and read your meter once a month or once every 2 months, you can be wasting a huge amount of water before we or you know it. I can't tell you how many horror stories we've dealt with people that had leaky toilets and couldn't believe how much water a single leaky toilet out in their guest quarters or something leaks. It leaks a huge amount of water if your toilet's coming on every 10 or 15 minutes and filling and drafting. If you're only reading meters manually once a month, that goes on for a month or sometimes 2 or 3 months before somebody finally gets a water bill and says, holy cow, why did my water bill just triple? With automated meter reading, the way automated meter reading works, the way the systems that are now being rolled out, and they've just put these in, by the way, in Glendale and Burbank. So these are real things. These aren't imaginary. The meters are read every night while everybody's asleep, and the next morning the utility gets a report of what happened at your house yesterday. So with a simple system like that, with an algorithm, we can be on the phone or in the internet that morning and say, we think you might have a leaky toilet at your house. You might want to go check. So huge opportunities for conservation. Studies have shown that just this kind of technology alone can save 10-15% on water by eliminating leaks on the customer side of the meter. This is water that might be leaking in your house, your irrigation system. You might have a leak, in your pipe in your yard, and you don't know it until it surfaces. It could go on for weeks or months. A system like this will notify us, and we can get to you the next morning, and you can reduce it. The second thing is, and this is something we're actively involved in right now, and everybody's pursuing this, is, you hear a lot about new rate structures. Irvine Rancher in Southern California has what's generally regarded as the best rate structure in terms of encouraging conservation. But before you can put in a new sophisticated rate structure, you need to have a computerized system to drive that system. And so we here in Long Beach are in the process of putting in a new, what's called utility billing or customer information system, so that we can go to much more sophisticated rate structures, which again will encourage conservation. When you put those two things together, you think about the power that those two things now give a water utility to educate your customers in terms of your water consumption and what's going on at your house. Basically we can communicate now with you real time through the internet or your smartphone or whatever. That's very, very powerful. The ability to communicate with the customers, educate them. Here's how much water you used yesterday. Looks like you might have a leak, or maybe you left your sprinklers on too long. Why did you run your water? Some people get a little nervous about this because we'll be able to tell that you ran your sprinklers yesterday during a rainstorm for a half hour. Some people might not like that, but quite frankly, that's the kind of capability that you have with systems like this. Why did you run your sprinklers yesterday in the middle of a rainstorm? But the water conservation potential of automated meter reading with a modern billing system and customer communications, I see huge opportunities there for conservation. And then the last thing I want to talk about, and what we're particularly proud of here in Long Beach, is our lawn and garden program, where we're tearing out grass and putting in California-friendly landscapes. In fact, yesterday we celebrated our 500th home that over the last year and a half has worked with us and torn out their grass and put in a California-friendly landscape. We're very proud to be what we consider to be the leader in this in California. We've spent a lot of time on this. In fact, when I was here a few weeks ago, I gave a presentation on lessons learned. We've done a lot of working with our customers to find out what works and what doesn't, and what we need to do to improve the system. One of the keys, quite frankly, is you need to offer enough money. One of the things we've learned is that offering somebody $1 a square foot for something that costs $5 to $10 a square foot, you might as well go fishing. It ain't going to happen. We offer $2.50 a square foot, and with $2.50 a square foot, we've got good participation. We've talked to some of our customers, and that's enough if you're willing to do a lot of the work yourself and look around. Most of your costs will be covered at $2.50 a square foot. So what we do is we offer $2.50 a square foot for 1,000 square feet. It has to be your front or side yard so we can see it. And so yesterday we celebrated. We had a media event. We were very, very pleased to have Jessica Hardy be our spokesperson. Some of you who are from Long Beach may know who Jessica is. Jessica is a world-class swimmer. She's the current world record holder in the 50 and 100 meter breaststroke. She's also the current world champion in the 50 meter breaststroke. She'll be a member of our Olympic team in London, and she'll be bringing home gold next year. And Jessica was so impressed with our water conservation program in Long Beach that she contacted us a few months ago and asked if she could help us promote the program. And I thought, well, where's the pro bono coming? And there is no pro bono. It's for free. We had an event yesterday, and Jessica Hardy, who was our spokesperson, and you'll be seeing Jessica if you're around Long Beach in public service announcements and stuff on our behalf promoting water conservation. So anyway, we're very, very proud of the program. Just some beautiful pictures. What we promote and what we really focus on is making it beautiful. It's not just about conserving water. It's about making your home beautiful, more functional, reducing pollutants and such that run to our beaches by not having to use so much fertilizer, and just making beautiful, beautiful landscapes. This one I particularly like because it's Spanish. The good news is, and this is really what I want to emphasize, is we've done 500 homes. Guess how many single-family homes there are in Long Beach? Someone take a guess. What do you think? Jerry, what do you think?
That's
Yeah, how many single-family homes do you think are in Long Beach?
100,000.
60,000. So we haven't even done 1% yet. You know, at the rate we're going, this is about a 120-year program. So we wish we could go faster, but so the point is there's all kinds of opportunity here that we're just starting to tap into. Anybody that tells you that we're done with conservation, that it's pretty much tapped out, that we can't do more, that's nonsense. It's absolute nonsense. If we can do this in Long Beach, this can be done throughout all Southern California, throughout all California. There's no reason why we can't reduce our water consumption another 10, 15, 20% easy with this, because typical family home uses 50, 60, 70% of their water in their grass. You cut that by 75 or 80%, you do the math. I mean, it's the math works. But you've got to get outside and you've got to reduce the grass and go to California. I was here a few weeks ago and I talked to a group. I actually did this in 2005. MWD did it for me. We made a little 30-minute video which ran on PBS stations around California. And one of the things that you find when you put in a California-friendly landscape is you don't ever water. I have a beautiful stainless steel, sophisticated irrigation controller. I haven't used it in years, so if anybody wants one, I'll give you my address. You can come take it off the wall tonight. You literally never water. You never water, particularly here in Long Beach. I mean, why would you ever water? You'll kill these things if you water. I haven't used my sprinklers in years. There's no reason to water your lawn like this. So you can save huge amounts of water. So now let's talk about why isn't this happening? Why isn't this happening throughout all of California? This is very basic stuff, but it's very important. And that's really what I want to close with, is why isn't it happening and what could we do to change it? Why isn't it happening? These are real issues, and I don't want to trivialize them. They're real issues. You all know that, and it just infuriates people when it happens, but when we conserve, water utilities always come back and say, well, now we're going to have to raise your bill because most of our costs are fixed, and when you buy less of our product, we have to spread that smaller amount of money across, or that same big amount of money across a smaller sales base, so our rates have to go up, and then you all want to fire people like me. That's true. That's what really happens. So there's a huge phobia in water utilities about the lost revenue that comes from conservation. Let's talk some real numbers. We buy water from MWD. I mean, we have groundwater. That's our cheapest source, but our marginal option is to buy water from MWD. Costs us about $800 an acre foot. When you meld our rate in, we sell it for about $1,100 or $1,200. So that markup is what pays for everything we do. If we don't do that, which is what happens when you conserve, we're not getting that $300 or $400 to pay for our costs of our salaries and fixing pipes and our electric bill and everything else. That's a real issue for water utilities. It's a real issue. That's what scares the hell out of water people, is that conservation is going to drive them broke. And I want to get to the solution, but I just want to let you know that's a real problem, and that's why a lot of people are scared of conservation. They're scared of it because it hurts their finances really, really bad. A couple other things that we haven't been very happy about is the shortage allocation plan here in Southern California. It's really a use it or lose it approach, and we wonder if those of us that are conserving will be protected or not in the future. There's no guarantees, but that's really not what I'm here to talk about. And then the other thing is, how do you pay for conservation? Now, conservation is cheap. Conservation's cheap. We're getting all kinds of conservation for maybe $100 or $200 an acre foot, compared to that $800 to buy met water. But again, it hurts you because you lose the sale and the revenue stream. So conservation is cheap, but you're paying money to hurt yourself. So how could we create a funding source? How could we solve this problem? How could we solve this problem that water utilities aren't scared or aren't financially harmed by conserving? And here's my proposal, and I'll close it with this. What if we did in the water business what's done all the time with pollution credits? What if we created a market? What if we created a market that areas that have a legitimate need for additional water supplies could fund those of us that are built out and want to continue to conserve. The math works. Again, their choice, if you're San Diego and your choice is to build a seawater desal plant that's going to get you all kinds of people mad at you, and it's going to cost you at least $1,500 an acre foot to produce desalinated seawater, which that's absolutely the minimum. Anybody tells you that is a fisherman trying to bait a big fish. If you instead of doing that could send, let's say, $1,000 an acre foot to Long Beach and have MWD take some water that they should have sent to Long Beach and send it to San Diego instead, San Diego would be ahead, and Long Beach would just have gotten enough money to fund conservation and be happy to lose that sale. So this all works. It's one of those miracle, economic things that all works if you let the market run. There's no market now. The reason there's no market is the same reason we had to quantify the rights on the Colorado River before we could do transactions between ag districts and urban districts. In order for a market to run, you have to know what you have before you can trade it. And right now, we don't know what we have. The way the quantification works in Southern California is there is no quantification of our rights that we have with the Metropolitan Water District. If Metropolitan Water District would quantify our rights and allow people that want to buy those rights, pay us to sell those rights, and we could invest that money in conservation, this would be the best thing for Southern California. This would be the best thing for Southern California, as opposed to spending billions of dollars on new infrastructure, which may or may not produce additional water. So that's my thesis, and WD would kill me if they were here right now, but they're not here, so I'm talking. It would create a revenue stream that would make conservation make sense. It would create a water supply for responsible new growth. Obviously, we want to make sure, just like in a pollution trading market, you don't let people that are polluting like crazy buy pollution credits and continue to pollute like crazy. There need to be, BMPs that are enforced that you can't just buy more. Rich people can't buy more water and sell it, so they'd have to be held to a level of conservation, which there are good standards already for that. And then the other thing this would do is create time. As Jeanine said, it's going to take decades before there are solutions to some of these issues if they ever occur. This kind of a market would create a buffer, a time buffer, to allow other things to develop and see if that. So that's my talk. That's your question.
Yeah, great.
Good, Jerry.
There's another huge advantage to natural using drought tolerant landscaping. It creates habitat that's good for birds, butterflies, insects, and so it really has an important role. With the, you said if we go more in this direction, we could save 10, 15, 20% more through conservation.
Right.
Right?
Right.
All right. Fast forward though, by 2050, the population in Southern California is up 25%. Easily.
Yeah.
Now, and by 2050, the imports are going to be less reliable. They're going to probably go down. So while I agree with you, we should do all of this, isn't it also prudent to be thinking about additional supplies, whether it's capturing wastewater, treating it?
Oh, absolutely. I didn't mean to discount those. I just wanted to present that this is something that makes so much sense.
This is the cheap.
This is something that makes so much sense. We should not hold back. What I'm really excited about, again, I like to learn from others and see case studies and things that have been done. What they've done in Orange County is just absolutely tremendous. What they've done in Orange County, for those of you who aren't familiar with it, they've now taken what it was 70,000 acre feet, and they're now expanding to 100,000 acre feet of advanced treated recycled water and using that to replenish their groundwater basin. We should be doing that everywhere in Southern California. If it weren't for institutional infighting that people and I do all day long, we'd be doing it. That makes so much sense, it's unbelievable. And someday we'll get there. There's tremendous opportunity to be doing those things in every groundwater basin throughout Southern California, to be taking recycled water. We pump millions and millions of gallons every day of recycled water into the ocean. We should be treating that and putting that in our groundwater basins to replenish it. So there's lots of things we can be doing.
And I know an aquarium, it's not too far from here, their attendance has gone up by 35% in 9 years, and the amount of water that the aquarium uses has gone down by almost 35%.
That is tremendous.
And it's a combination of waterless urinals, dual flush toilets, tearing out some of the lawn, drought-tolerant landscaping out front, California native in the back,
Yeah.
and having a sophisticated watering system
Right.
that is triggered by satellite.
By satellite. Good.
And so it can be done. And I don't know, have you cut our water rate though because of all of our practices?
We put in a new rate just for you. No, we haven't. One of the lessons learned is you don't put in a new rate structure and raise rates at the same time. That's a deal killer for water.
Bring the lights up a little bit, Keith. Let's have some discussion. Yeah.
So Kevin, first of all, thanks for a great talk.
Thank you.
We are in somewhat of a unique situation in Southern California with Metropolitan, if we could get them on board, right? I mean, seriously,
They won't do
you'd
that.
have to do this, I mean, this would work beautifully, because San Diego has no groundwater capability,
Right.
and we do.
Right.
And so what we have to do is we have to look at it as a system, and what we have to do is we have to get Metropolitan on board to look at it as a system rather than the way they're doing it. I don't think they're looking at it so much as a system, but I think that's the key here.
Metropolitan would have to create this bank. They would have to do it. They'd have to be the market makers.
Right.
So you can direct questions or comments to Jeanine. You should come up here too, be in the line of fire here. Yes, go ahead.
Hey Kevin.
Yeah.
My name is Wattier. I work for the city.
Hmm.
Can you talk about the local desalinization project that's been ongoing and kind of what's...
Yeah, we've had a seawater desal program in Long Beach for about 8 or 9 years. We built and operated for 3 or 4 years a membrane plant over at the Haynes plant, LA's Haynes plant. We've completely demobilized that now. It doesn't exist anymore. But what we demonstrated there was a new membrane technology which reduces the energy consumption about 20%. And then the other thing we have, and it's still operating, it's right over on down below the Long Beach Museum of Art on the bluff there is what's called a submerged intake. It's basically like I always hate to use this analogy, but most people understand it. It's like a septic tank leach field where water's percolating down through the sand and into these leach pipes and then into what could be a seawater desal plant. That's actually something that we learned about that's been operating in Japan for about 6 or 7 years now. It works great. So we've proven you can reduce the consumption by 20%. We've proven you can build an intake that has no environmental impact on fish. But what we can't do is make it cheaper than imported water. Even with those improvements in energy consumption, the energy consumption is about the same as imported water from Northern California. We'll never beat their price. You guys have the cheapest power rates on the State Water Project that anybody will ever get. So people always ask me, will there ever be a time when the price point changes over where seawater desal is cheaper than imported water? I say probably not. It's because it's just simple economics. Right now, imported water is about $800. If you could do a seawater desal plant for $1,500, I'd be amazed. So seawater desal, as we sit here today, in Long Beach's opinion, is at least twice as expensive as imported water. So we're not there, and we're not going to spend your money on that. Whether we ever get there or not, I don't know. But I think there'd have to be a further breakthrough on energy consumption because you're competing with very, very cheap power on imported water.
Because it's subsidized.
It's not subsidized.
If you look farther down in Southern California, I asked you this
Yeah.
over dinner. If you look at
I think it makes more sense in areas that don't have the options that we have, that don't have the groundwater basin, that don't have the recycled water options, that when you get down to San Diego, they don't have as nearly many options as we do here in Long Beach. So again, that's the kind of thing that I think will make sense for inland areas like that.
Now, if we expand our horizon, not just to Southern California, but to more of the state,
Mhm.
what percentage of developed water goes to agriculture, Jeanine?
Depends on how you want to slice that deck of cards. There's 2 ways to look at it. One is, the traditional way that
Okay.
Take that.
the statistic has always been presented is that ag is around 20% urban. Ag is around 80%, urban is around 20%. However, another way we've looked at it in the state water planning process is to talk about also let's recognize the water that has been set aside for environmental purposes, such as the wild and scenic rivers, in-stream flow requirements, etc. If you do it that way, it's more like 40-40-20. Ag 40, Enviro 20, and Ag 40, Enviro 40, and urban 20. So roughly same ballpark.
But it's still a high percentage, and high relative to most other states. Now, we have the largest agricultural economy of any state in the country, more than twice number 2 Texas. But aren't there big savings that we could achieve in agriculture by not growing certain crops and having more sophisticated irrigation systems?
Actually, I'm glad you teed that one up, Jerry, because it's a really common target for people in the urban sector to poke at ag, and they think that water drives the ag sector. It does not. What drives the ag sector is crop markets. So people can say, well, gee, it would be great if you planted more water-saving crops or whatever, but what they really don't realize is that the market drives what growers plant, and they will plant things which are actually the most cost-efficient in terms of production per bushel or ton or whatever it is of whatever it is they're growing. But something that you can really clearly see that water and crop prices are often quite divorced from each other. In our last couple of significant droughts, 87 to 92, and actually the one we just finished up with recently, farmers were doing quite well financially because conditions in other parts of the world, like Australia, happened to be really horrible, which caused the price of some of the major crops to grow up, and therefore they were doing well even though water was scarce and prices were high. So remember that the farmers are there it's a business decision, they're there to make a profit, and it's sort of a different way that you view it.
Right. Do we adequately or accurately, appropriately price water in this state?
No.
Most folks would say no.
But I'm not disagreeing with what you said, but given a state where we have these water issues, should we be growing alfalfa and cotton and rice?
Well, that ice cream that you said you liked so much at Interferry, that was directly related to that high-protein alfalfa that the cows ate to produce the ice cream. And that is why California grows so much alfalfa, actually, is because of the dairy industry, which happens to be one of California's top value cash agricultural products.
Come on, save me, Kevin.
I'm not going to save you, Jerry. She's tough, man. But no, the other thing I would add, it's interesting, unintended consequences, and just something I think we should all be paying attention to. I think probably the biggest ag to urban transfer in the United States is the transfer from the Imperial Irrigation District to San Diego. So that's Colorado River water. And the way the way that deal is supposed to work is they're supposed to conserve water out in the Imperial Valley and then transfer that conserved water to San Diego through MWD's aqueduct system. The unintended consequence of that is when they conserve water out in the Imperial Valley, that water no longer flows to the Salton Sea. And the Salton Sea, which is already much saltier than the Pacific Ocean, is getting saltier and saltier. So that's an issue where conserving sometimes causes unintended consequences. The other thing that we should all be paying attention to, because I think the oral argument is coming up in the next couple of weeks, is that what's called a quantification settlement agreement, which provides for those kind of transfers, was ruled illegal, and now it's on appeal, and it's going to be held in the next couple of weeks in San Francisco. And so just pay attention. That'll be in the news in the next few weeks. You'll see a lot about whether or not that kind of arrangement can even proceed in the future. So the reason it was ruled to be illegal was because the state, under our previous 2 governors ago, signed a commitment to fix the Salton Sea, and that's not happening. So we'll see.
No, technically what we signed the commitment to that the judge found unconstitutional was that the state committed to accept unconditional liability for the environmental impacts of the transfer above a certain dollar level.
Okay.
Do you think we give adequate conservation in the Colorado? Look what we've done to the Gulf of California, the Sea of Cortez. Used to be a magnificent estuary, a delta the size of the state of Rhode Island. Virtually no water goes into the Gulf of California. Why don't we, in California, give up our 18% contributed to nature and restore that?
Did you want to comment on that?
Down it.
Yeah.
Yeah.
Last time it rained, I tasted the water. It was real sweet, and it was clean. Now we have a natural desalinization going on with all the rain that we have. Why don't, and yet you see this water run into the ocean. Why can't we just capture 90% of it at least, or 10% of it? You can't do anything better than that. And capture the rain that is being normally desalinized by nature.
Well, a lot of,
Can't we just capture it?
here at the end of the ocean, at the end of the two biggest sewers in California, I mean, that water coming down here, I hope you don't swim in it. The water coming down the LA and San Gabriel rivers most of the time is not something that we actually, just to give you an idea of how difficult that would be, we actually are doing a study right now to take some of that water out. And I got a call from one of the top people at the state health department, and they said, if you lost your mind, we're not going to let you do that. It's the contamination issues in the LA and San Gabriel rivers are difficult to deal with from a public health basis.
Maybe.
Teeing off that, I think that, I see when it rains, and we're doing a lot of stormwater work down in Orange County right now. But if we could just start to have eaves troughs in local cisterns, I mean, that would be one way to minimize this. I mean, when we get our 10 inches of rain, it's enough to keep us going the whole year if we can capture it. Right. The problem is we're too cemented, and we can't capture it. We can only capture it locally. And the problem, there is another problem with the stormwater, and that is that first flush is pretty nasty. Because it's going to have organics from your cars and heavy metals and dog pee and stuff like that. So you got to get rid of that first flush, but then it becomes very good water even off the road. And we have to figure out how we can capture that, but we don't have an awful lot of storage space unless we do it individually.
Yes, go ahead.
That kind of piggybacks onto my question, which was, can the individual homeowner capture the runoff from their roof? And does the city have any resources to help them figure out how to do that?
Well, we'll give you a rain barrel for that if you want. We have rain barrels. But one of the problems with capturing water here in Long Beach, and again, this is a very significant issue, is our geology just doesn't work.
I mean, just to have it stored so I can water my garden.
If you want to store it with a rain barrel or capture it on your property, that's perfectly fine. But people always ask, why don't we capture the local water here and percolate it down in our groundwater basin? The reason is that as the San Gabriel Mountains eroded over centuries and centuries, what happened is the large rocks and gravel settled out at the base of the mountains. And so that's a very nice granular aquifer up there in the San Gabriel Valley. But the really fine, silty clay stuff, because it's lighter, got down here to Long Beach. So when you go down and dig a hole in Long Beach, what you find is that the upper aquifer is completely unusable for any kind of a groundwater supply because it's very, very fine, silty clay. It doesn't hold any water to speak of. And then below that, you have completely impervious 50-foot thick clay layers. So the good news is that nothing we do on the surface here in Long Beach gets down to our potable drinking water. The bad news is you can't percolate water down here in Long Beach and replenish our groundwater aquifers. It's completely isolated from the surface by several thick clay layers that don't let that get down there.
I'm going to do a little follow-up on that to give you a sense of perspective with some numbers. If you look at MWD's imported supplies on the Colorado River system, think about in terms of 1 million acre-feet a year, something like that. If you think about the amount of groundwater that's recharged annually, average annual basis in Orange County by Orange County Water District, around 300,000 acre-feet a year, similar ballpark that LA County recharges through its system of capture in the upstream little small dams up in the San Gabriels and then flow down to your spreading basins. But one of the big constraints in a really urbanized area here is the ability to have enough land to spread that water over. When LA County first started doing that, and they were actually one of the original developers, if you will, of this managed groundwater storage concept, they started around World War I, some of the earliest facilities, and there was plenty of land available then to do it. And if you look at some of their biggest spreading grounds, like the one on Rio Hondo, upstream from here, that's a large piece of property. But to do something new like that today in this area is pretty much highly impractical because you just don't have the land area.
Over here and then go over there. Yes, go ahead.
Thank you for that absolutely perfect segue. I'm with LA County. I'm with the LA County Flood Control District, and the question that this gentleman and other people have brought up is about why don't we capture more is something that we are actually looking at, and it's there is a perception that we don't capture a large percentage of what falls on the watersheds in, say, in the LA River, San Gabriel River, but in the San Gabriel River watershed, in total, we do capture a great deal of it and infiltrate a great deal of it. Typically, close to 90% of it. However, in the LA River watershed, lack of certain types of facilities, dams especially, limits our ability to capture water in that watershed, and we're only capturing about 15%. So there's a lot more opportunity in that area, in the LA River watershed, to capture more. But as we were saying, the ability to infiltrate it is limited because we live in an urbanized setting. So yeah, we are looking at that, and since most of our facilities are up in that foothill area that Kevin was talking about, where it's most closely connected to where you can get it into to recharge the groundwater basins. That's where we're looking at doing some study work connected to climate change considerations to see if we can do more. Since that's really where most of the rainfall falls. If you go to the coastal areas, the average rainfall on coastal areas is relatively small. Go a little bit further inland in the valleys, a little bit more. But once you get in the mountains, you're talking about 2 to 3 times as much precipitation as you would find down here in the coastal basin or the valleys. Correct. And really, that's where the biggest opportunity is to capture larger amounts of water that's relatively clean and not contaminated from urban runoff.
Good point. Over here. Yes, you had your hand.
Oh, okay. Yes. So my question was regarding what you were saying, Jerry, about why don't we charge more for certain fruits and vegetables that we grow that require large amounts of water. And Jeanine, you said it was because the market dictates what we're growing. They're just trying to make a living selling what people want. If we did charge more water, wouldn't that cause the prices to rise and dictate what people would want and would be able to afford?
Actually, it would probably drive more of the production out of the U.S. There's been a major shift over, say, 3 or 4 decades of production of crops that we're growing in California, let's say, or in the U.S. to other places. The cut flower market, for example, is primarily all Central America and Mexico now. A lot of your winter vegetables and specialty crops that command high prices are all Mexico, Central America. One of the things that worries the agricultural community is the continuing, competition for much areas where the prices for labor are much less and environmental regulation is much less. You can look at some of the crops that were grown in places like Imperial County, for example, where the water transfer that we were just talking about is occurring, and you will see that some of those crops have moved entirely to Arizona or Mexico, more because of cost of labor and pesticide permitting issues than water. But, agriculture does work in a global market, and if the conditions aren't favorable in California, it will go elsewhere.
Did you have your hand up? No? Okay. Whoever, yes, go ahead.
Hi. Does Long Beach or LA have any other programs for recycling water, such as rainwater or anything like that homeowners can implement on their own
Yeah, the city, with our help, has a gray water pilot program that they're actually recruiting people that want to volunteer to get a free system right now. It's being run by our city's sustainability department, but we funded it.
Is that going anywhere?
I don't know, I haven't heard, but they're spending our money. I hope they're doing something with it.
Other questions or comments?
I have one sort of.
Go ahead, way over there, and yes.
Okay, this is going back to the California native lawn to garden issues.
Mm-hmm.
Have there been any studies about temperature change in and around that home that now has the more arid landscape? I mean, the outside of it compared to having grass, is there?
I'm not aware of any, but one of our requirements is you have to have at least 60% of the ground covered with plant material. We don't want a bunch of rocks. So, you know, I don't, it hasn't been an issue that we're aware of.
That hasn't been an issue?
No.
Actually, I was just going to chime in. I was tempted to chime in on that one when you were talking earlier, because we have another complete discipline and branch of government, namely the health department, in this case the California Department of Public Health, that's working on the heat wave aspects associated with climate change. And they are extremely interested in the greening sorts of things, planting more shade trees, et cetera, because they're looking at that as an answer or something that will help out with the heat waves. So some of this very xeriscape type landscaping that doesn't include big shade trees is probably antithetical to where they think they're going.
But it can be a combination, clearly, of the two. Kevin, do you get good cooperation from our city parks department?
Yeah, we really have gotten good cooperation with our city parks and rec. In fact, we just funded, we just authorized $1.5 million for them to re-landscape a lot of important areas around town, and they just came in and proposed about 7 or 8 sites that they're going to be re-landscaping.
So that's great progress, because I can remember
very pleased with
years
that.
ago,
yeah.
They felt that by getting rid of the nice, expansive green lawns, it would increase vandalism. And
oh, you look at some of the work the city's done recently. I mean, if you come into Long Beach from on 2nd Street on Westminster, they've done a beautiful job. They're re-landscaping the area that we're. So they're really coming along. I like it.
Go ahead.
I asked a question in a couple of classes back. Do you think water is underpriced, and to do some of the infrastructure upgrades that we need to do? You talked about cap and trade, but what's the typical funding mechanism? Is it bond measures? Is it rate increases? How do we fund the infrastructure upgrades we need if we don't get a cap and trade system?
Well, first of all, there's legal requirements. One of the, I don't know if this is really responsive or not, but we can't charge, one of the things that some people always suggest is we should just jack up the price. It's not legal for us to do that. Under the California Constitution, we can't charge people whatever we feel like for water. We can only charge what it costs us. We have to have a true cost of service basis for our rates. Prop 218 and subsequent lawsuits have made that real clear. So a lot of people will say, well, you should just jack the rate up and that'll solve the problem. It's not legal to do that in California. But we get all of our revenue from our customers. I mean, we do a little bit of chasing state and federal money, but 90+% of our money comes from our customers. It comes from you in the monthly water bill that we collect from you. And to me, it's not a problem. I mean, I hear a lot of my colleagues in other water utilities whining about they don't know how they're going to pay for things. I quite frankly don't understand what the problem is. We're doing a great job in Long Beach. Our water rates are some of the lowest in the state. We have, in my opinion, the most progressive infrastructure rehabilitation program of any water utility in California. I mean, we replace way more water line per mile or per capita than LA and others. I don't know what their problem is. I mean, they're not here so I can talk about them. But to me, people always want to make a problem out of this. This is, to me, this is not a problem. It's not a problem.
So you do roll that into your rates?
Yes, that's all fine, but we can't just say, well, now because we want conservation, let's just raise it another 50%. We can't do that.
Yeah, but what you're doing makes sense. I don't understand why the other people have the problem either. I mean, it just doesn't make sense.
Well, to be honest with you, a lot of the problem you have is that, and this is the structure of their government. You have a lot of cities where the water department is not independent, and their city steals from them. That's illegal, but it happens. if you read the article about the city of Compton that was in the paper a week or so ago about the fact that they may go through municipal bankruptcy, one of the problems they're having with their water department there is that their city is stealing from their water department. And it's not legal, but they're doing it. City of Glendale recently canceled their multi-million-dollar transfer from their water department to their general fund because their city attorney advised their council that you should probably stop it before you get sued and lose and have to pay it all back. Same discussion going on in the city in Fullerton. I won't use the name, but the Howard Jarvis group is very active right now in the city in Fullerton trying to stop an illegal transfer from their water department to their city's general fund. I never thought the Howard Jarvis guys would be my best friend, but they are, because they're stopping these illegal transfers. You have a lot of situations in California where cities are stealing from their water departments, and it's not legal and it's happening.
All right, we're going to bring this to
Jerry wants to close this before we all go
we're
to
going
jail.
to bring this to a conclusion. By 2100, we know we're going to have higher temperatures, less reliable water supply from imports, higher sea level, more frequent, prolonged, severe droughts and floods. In Southern California, we're going to have 25% larger population, at least maybe 40% by 2100. So I want to know what collectively, what's your 5 to 10 point program to make sure that Southern California has a reliable and adequate supply of water by the end of the century? What's the first thing you would do? Then you're going to do number 2. We're going to.
Okay. Well, conservation obviously is mine.
Conservation.
Link land use development with water supplies, which is one we haven't really talked about here tonight.
Much better utilization of our groundwater basins. They're very, very inefficiently managed right now because of bureaucratic infighting.
We need to rework some of the stormwater systems down here.
Recycling throughout Southern California, like Orange County showed us the way out.
We need to better manage some of the groundwater basins with respect to salinity, and also manage salinity in groundwater generally in Southern California, because that's necessary to allow recycling programs, for example, to happen.
And in the aggregate, would those things, if done properly, provide an adequate and reliable source of water? No. What's missing?
We're missing the dealing with the long-term loss of the Sierra snowpack, and assuming that the political will is not there to control growth, which I think is or to control land use much more tightly, which I think is a pretty safe assumption. That means we do need to think about augmentation, and in fact, something that's going on right now in the Colorado River world is something called the Basin Study, which the Omnibus Public Lands Act of 2009 authorized and directed the Secretary of the Interior to do certain things to respond to climate change. One of them was to conduct these, what are called basin studies, to assess, well, first of all, to project future water needs, and then assess how you might meet them in an environment that includes climate change. The preliminary results will be actually next month. There'll be a series of public outreach activities for the Colorado River Basin, and you'll see demand projections that are a couple 3 million acre feet, of unmet demand in the future. So that will be an interesting exercise.
So we need to augment supplies, and it will vary by region in terms of what makes a sensible addition.
And also, we also don't want to forget the flood control side, because we have an opportunity here as part of a land use process or a zoning process to try and control development in sensitive areas like alluvial fans, and especially the apex or the upstream end of the alluvial fans where the good groundwater recharge areas are.
And get rid of those darn cows, and I'll buy my ice cream at Ben and Jerry's in Vermont. Bill.
I think the thing that concerns me about long term is this importing the Colorado River. That comes in at 1,500 milligrams per liter of salt, and we're bringing in 2 million tons of salt a year or something to Southern California from the Colorado. That ultimately is going to kill the soil, so I think we have to wean ourselves off the Colorado River somehow.
That's a pretty big chunk of water to be missing. And you've heard of the Southern California Salinity Coalition, I'm sure.
Yes.
Okay, so, you know, it's not something that people are ignoring. And as a matter of fact, one of the things that's been very successful overall in the Colorado River is the Colorado River Salinity Control Plan, in which some of the water users in the downstream end, including MWD, USDA, Department of the Interior, are putting money into doing measures in the upper basin to control naturally occurring salinity so that we get less salt loading down here. And Jerry, you were kind of alluding earlier to ag water use. You go up in parts of the upper basin and look at what they're doing in terms of irrigating what's, you know, basically grass pasture, it's not even hay, over extremely saline soils, which the Salinity Control Program is paying beaucoup bucks to. Yeah, that makes you really worry. Our agriculture in California looks so good compared to that.
Yes. I think one thing that's very clear is that water in California is what's called a wicked problem. It's a problem. Wicked problems are problems that cannot be solved. They can never be solved. They can only be managed. And therefore, you stop this nonsense of looking for the silver bullet, the optimum solution, and you look for a portfolio of solutions that in the aggregate do what is called, you minimize regret. And it changes the way that you approach these kinds of problems. Things like healthcare, wicked problem, climate change, water. And when you take one piece of it, you can get an elegant solution to the wrong problem, and it has all kinds of unintended consequences. It is far better to have an inelegant, incomplete solution to the right problem than the wrong solution, than the right solution to the wrong problem. Join me, please, in thanking both Kevin and Jeanine. A special hand, this one's only for Jeanine, not Kevin.
That's
because
good.
she put this together.